Functions, we're all about the functions tonight. A couple announcements, and then we'll get right into lecture. And then you've got studio on chapter 10, and then we'll come back at the end of class, as always, to do the studio review. And I will kind of, live code that, and we'll talk about it to make sure everybody understands, how we come up with the solutions that we do for these things. And now that you guys are getting into writing functions, you will find that the thing I keep saying is really, really true about how there are lots of different ways to do things. And so you just make decisions as you go, and you find a way that works. And it might be completely different than another person does it. And of course, when you work together in studio, you help each other arrive at those things faster. So this is a great studio to work together on. Most of them are. So let's see, I'm gonna get rid of this. All right. So let's go to announcements. Of course, you know that the graded assignment deadline, the enrollment deadline is Monday. And I mentioned that already, but I will reiterate it. Just knock it out this weekend. Go to office hours to get support from your TAs. Put in the time, and you'll get there. I know you get stuck and you get frustrated, and it's hard and stressful. But this is where all of these concepts come together. It's where you get a chance to actually build something a little bit more complex than these smaller exercises that you've been doing. And there's an immense sense of satisfaction when you make that all happen. So that's Monday. And then I want to talk about lecture flow. We've had a really intense couple of lectures based on the pure amount of questions that are being asked. And I want to tell you guys, first of all, I've had classes before where nobody talked, and it was miserable because I'm getting nobody's answering my questions. Nobody's asking me questions. I hate that. I love that you guys are, asking tons of questions and engaging and answering me when I ask questions. That's awesome. But we also have a lot of material to get through. And so I'm trying to think of ways that we can meet in the middle so that we get through all the material and we're not having to hold Saturday sessions to finish it. But we also, still able to answer some questions, right? So one of those tools is lecture questions channel, which the TAs will be monitoring whenever they're available. And tonight your TAs are going to be grading your part 2 of your assignments. But I know at least Selena, when she's here, she's going to be helping out since she's a floater TA. So you can ask questions there, and even your peers, can answer questions in some cases. And then I'm going to stop at a couple points to actually take questions live and talk through some things. We'll just have to do it in limited spurts just to make sure we get through all the content for the lecture. But the main point that I want to bring up here is that we told you the first night of class that the bulk of your learning is done outside class, right? And one of the reasons that we give you prep work to learn some of this stuff before you come to class, rather than doing it as homework after you hear the lecture, is so that we can spend the lecture time going into it in a little bit more detail, putting things together in ways that aren't introducing it to you for the very first time. So one of the things that's going to help with the questions being asked is just make sure you're doing that work before you come to class. You'll be able to track a lot faster with the things I'm talking about if you already have that basic understanding, because you did the reading, you did the quiz, you did your exercises, and we're just basically going back over it, looking at it from a slightly different point of view, maybe talking about a couple things that are, kind of the next level up and building on it, but not, hopefully none of you are hearing things for the first time when I'm talking about them, because it's going to be very, very hard for you to keep up if you are. And I'm sure that's probably what some of you are experiencing sometimes. And I know there's been some people who've, had family emergencies or been sick, and you get behind, and that's okay. We will work with you within reason, but I just encourage you to make sure that you're carving out time ahead of lecture to get this stuff done. Okay. And I'm taking up time talking about this, so I'm going to stop. That's all I have to say about that. So I want you to speak up. I want you to feel free to engage. I'm going to keep asking you questions. We're going to talk. We're going to dialogue. But if I say we have to move on, I'm going to keep moving forward, and then we're going to kind of see where we are with time. Okay. So functions, this is where you put code to work for you. I'm going to talk about this concept of a black box, talk about some of the familiar functions you already have seen and used. What are the kind of fundamentals of creating a function? How do you go about using functions in your code? What do you do if you want to have optional parameters and you can give them default values? And then we'll talk about function composition, which is very important for your studio tonight. You're going to do this in studio. Okay, so the black box concept. This is where you have input and it goes into this mysterious black box and something happens to it, and then you get output or some sort of result, right? And generally speaking, if the code inside the box is working properly, you should always get the expected output for any input you give it. That's the goal, right? So a couple very straightforward examples of this would be, you know, you put in 3 and you put in 5 and you put in 9. And when you put in 3, you get 9. And when you put in 5, you get 25, etc. So what would you say is probably happening inside this box right now?
Square root. Multiplying by itself.
Yeah, it's squaring it. Exactly. So, you know, 3 times 3 is 9, 5 times 5 is 25. So, you know, you can rely that however that code was written, you can get the right answer every single time. You just put the number in and you get a new number out. Similarly, you can do this with, you know, text. So, you know, we've got these short strings, pig, fox, and cat. And when they come out, they've got capital letters, there's spaces in between them, but it's consistent, right? Same exact result, no matter what you put in. So this is the idea, is that, you know, this is how functions work. They're encapsulated and you just want it to be able to work. You want to be able to trust it. And the thing is, you guys are the programmers now. So you get to design what's inside the black box and make sure that it's going to do its job. And that's what we're learning how to do. Okay, so let's talk about some of these familiar functions, right? You've already seen a lot of functions. You've seen the special functions for data type conversion with JavaScript, number, string, and Boolean, probably the only functions you'll come across anytime soon that start with a capital letter. They're usually camel case, right? But yeah, you've seen those at work. You've seen in your graded assignment, you've seen this run program that's calling, you know, ask question and grade quiz and all these things that the launch code staff put together as kind of the architecture for this program that you're running. And you've seen the console API, the log method, console.log, that, you know, takes this string and prints it to the console, and the readline sync library that has the question method. And remember that methods are just functions that are attached to something, right? So, you know, you say you've got this input object, you ask a question, it says, okay, I'm going to print that to the console. The user is going to enter something, and then I'm going to return that value to you. And the string and array methods, there's so many of them, right, that we went over a week ago or so. And all of them function a little bit differently. Some of them just go and do something. Some of them like permanently, you know, like change an array. And then some of them also return a value, right? And if it's a string, it certainly always returns a value because we don't mutate strings directly. So you've seen lots of examples of how these functions are working, whether they're, you know, straight functions or methods. But now you're going to learn how to design them for yourself, because you were just kind of like, oh, I don't know how it works. I just know that I can use it and I get the result I want. So this is the other side. This is the flip side. You're learning how to write them now. Okay, so anatomy and terminology of functions. You use the keyword function. You give it, always with the transitions, my goodness. Okay, give it a descriptive name using camel case. And it's good to use a verb noun combo. So in this case, I've got greet user. It makes it very clear, this is what this function is designed to do. It's going to greet the user. You always have to have the parentheses after the function name, but you don't necessarily always have to have parameters inside. It just depends on whether your function requires input or not. We're going to have lots of examples of looking at, you know, when you do this, when you don't. The code to be executed goes inside the curly braces. This should look familiar now, this structure, right? You've done it with conditionals, you've done it with loops. The same idea where you have code inside the braces that gets executed when the function is called in this instance. Everybody check their mics. We got somebody with an open mic. All right, so in this example, we've got, oh, right. I forgot to mention the return keyword. The return keyword is actually optional. If you aren't returning a value, you don't have to have it. We'll look at examples of that too. Okay, so you've got your keywords, function that defines that everything that follows this is going to be a function. So JavaScript knows what to do with it. And then of course the keyword return inside the function if you're returning a value. The function name, parameters if you require input, and then the function body, everything inside the curly braces. Okay, so parameters are variables. This is a very important concept to understand, or else it'll constantly be confusing to you how functions work. If your function needs to take input, assign parameters to represent the data. And you use descriptive names of camel case, just like you would for any variable. Parameters can be used as variables anywhere inside the function body. They are scoped locally. So like, let's say in this example, we've got this format, social security number, right? And we know social security numbers are broken down into 3 parts. You've got the first 3 digits, then 2 more digits, and then the last 4 digits. And I have used this a lot in my work, actually, and they're typically stored as strings, not numbers. So, it comes in 3 strings. And let's say you need to turn around and you need to format it so that it looks like, you normally want to see it so that you can put it on the page for the user to see their social security number or something. Then we can have a quick function that just takes those 3 parts and puts them together. And we're using string interpolation here, right? So if we have said when the data comes in, we're just going to call these parameters SSN1, SSN2, and SSN3, then that's what we use as the variables to pass that data to the code that we need it for when we pass the data into the function. And we'll look in a few minutes at the flip side of this, which is actually calling it. But you're seeing an example of this already below, right? Format SSN, I'm calling the function, I'm passing in these values, 1, 2, 3, 4, 5, and 6, 7, 8, 9. So what do I expect to see? What's the return value that I get from calling that function?
1, 2, 3 hyphen 4, 5 hyphen 6, 7, 8, 9.
Yep, exactly. It's just a nice formatted number, right? And technically it's a string. I don't have the quotes on it, but it's a string. Yeah, exactly. So we used our parameters as variables. So let's talk about scope with variables. I mentioned before about how parameters can only be used inside the function, right? They're not available outside. So it's very common to use other variables too, not just parameters. And it's common to use ones that were declared outside the function. So the parameters have local scope only, and any variables that you declare inside the function with like let, or if you have a constant declared with const, those are local as well. But if it was declared outside the function, it's available outside and it's available inside. So here's an example. We're getting user input. We ask the user for their name. We store it in this variable name. Let name equals input a question. Give me a name. And then we write this function, greet user, and it takes a parameter message. And so then we build this greeting, and we have a local variable inside the function called greeting that creates this string where it puts together the message with the name. And you're going, okay, the message I get that came from the parameter, where did name come from? Well, that's that variable that was declared a couple lines before that outside the function, right? We can use it here. This is very common. So I'm putting these together. What was passed into the function, I'm putting it together with the name that has been stored after the user gave it to us. And then I just log that out And that's the end of the function. I'm not returning any values. I'm just logging something to the console. So we call the function greet user and we pass in good morning as the message. So if you look, skip past the console logs for a second there, and let's look at the bottom. So in the console, we ask them, give me a name, and they come back and they say Ella. And we say, okay, greet user, good morning. And so there we go. Good morning, Ella, right? Because we have put this together with message and name into one string, and that's the greeting that we log out to the console. So here's the question. Console.log has, I've got 3 of them here. The first one, name, is okay because the name is in scope. But what would happen if I tried to console log message or greeting from here?
It's not been declared.
It wouldn't exist.
Yeah, you get a reference error, right? And I can demonstrate some of this for you. So before we move to the next slide, let's come over here. And I actually meant to do a couple other things here too to show these other ones. So let's do this one and then we'll come back. So greet user. All right, so we get the name and then we greet the user and console log the name. So we run this, everything's great, right? So I say Tracy. So good morning, Tracy. And then it logs out Tracy because I put that down here just to test it, right? So here's where the rubber meets the road. We go and we say, okay, I also want a console log message, right? So we run it again and I say, Kevin. Good morning, Kevin. And then it says reference error, message is not defined. And we would find that the same is true if we switch over to greeting, right? Run it again. And now I say Bob. Greeting is not defined because in both of these cases, these do not exist outside the function. And here I am outside the function trying to access them, but I can't because they only exist inside these curly braces right here. Is that clear? So these are good things to keep in mind because you are probably going to run into some issues and occasionally that might be why. So just always pay attention to your scope. Okay, let's see. I had another scope example here, but maybe I have these out of order. Let's go back to the slides. Yes, I do have them out of order. Okay, that's cool. We'll go back. All right. So there's this concept of shadowing. They talked about it a little bit in your book. And I wanted to give you an example of kind of what happens. So shadowing is this concept where you can have a local variable inside your function, and it can be the parameter, or it can be like something you declared with let or whatever inside the variable. And you will, if you create something that has the same name as a variable that existed outside the function, there could conceivably be concepts. However, surprisingly, JavaScript allows it in certain instances, but it's a very bad practice. So I'm telling you now, don't do it. It is much better to have clarity and prevent confusion. So here's what happens if you do it anyway. So this is bad, but I have this variable color and I've established that it's black. But then I've written this function, describe item, and I'm giving the opportunity for us to pass in not just the item, but also a color, like a color to be a variable. Like we can change the color, right? But it's got the same name. So I console log, it's a color item, right? And I use those, variables names. What is going to get logged out if I call this function describe item and I pass in box and blue?
A blue box.
Yeah, it's a blue box because JavaScript is going to default to using the local one rather than the one that's outside the function if they have the same name. So at least it doesn't break your code. So then later on, after that, I say console.log color. What am I going to get when I console log color?
Black.
Yeah, because that's the only one that's in scope if I'm outside the function, right? So as you can see, this could potentially just cause a lot of chaos in your code, and it's just better not to ever have variables that can be confused for one another. For your sake, for future people's sake who are working on your code, yeah, just don't do it. And I skipped ahead and didn't mean to, but let's go back over here. Yeah, so let's come back to that, and I'll just show you like the other thing that could possibly be is, what if I also said let color equal red here? What would happen if I run this now?
Red.
It's a red box.
It'll be blue box unless you don't define a color, then it would be red.
No box.
Red box.
Okay, I'm gonna hit run and we're gonna see. Now it gives us a syntax error and says color has already been declared. Now this is because now we have 3 variables, not 2. We have the parameter color here, and then we have the one we declared again. And these are the 2 that are in conflict with one another. So if I didn't have this, and I just went ahead and, you know, and I could get rid of this, right? And just say, I'm only gonna have them pass in the item. Then it's just a matter of it trying to decide between black and red, and it's gonna choose red because that's the local one. But you can't have both a parameter and a local variable be the same name, or it'll give you an error. But it doesn't give you an error when it's a conflict with one that's outside. That's called shadowing. Okay, so I've seen some hands up. I'm going to take a second to take questions. So Mike, you got your hand up?
Just real quick, if you would have removed the let from in front of color equals red, would it have, it's not going to return that, right? It'll take red as the new value.
Yeah, and this is a very interesting, okay, so you brought up something interesting. Let's see what happens, because this is, yeah, because are we replacing this one or are we replacing this one, right? And you know, I know what I think. So let's log both of these actually and see what happens. Oh, I have to put the color back in. Okay, there we go. All right. Okay, so it says red box and black, because this is just changing the value of what came in. So it didn't matter that I passed in blue. It overwrote it and said, nope, we're going to make it red instead. But it's still changing the local one because JavaScript is going to default to use the local one instead of the external one. Yeah, so I can still console log color here and color is still black outside. Yeah, good question. Okay, let's go back to the slides and let's talk about early returns. This is a good concept, something that I don't think I figured out right away as a student, and I was glad when I learned about it because it made things easier. The return keyword will always stop the function from continuing to execute its code, which is why typically you see it at the end, right? Because you want to execute all the code and then you quit. But there are times when it is helpful to have an early return. This is one of those times. So let's say we've got this, I got to figure out here. Oh yeah, here we go. I've got this example, divide nums, pass in a couple of numbers and try to divide the first one by the second one. And I've put in a condition to say, if the second number is 0, then return something completely different. I don't want you to just return, you know, num1 divided by num2. And the reason for this will become apparent in a second. And it's just, so it's like, I want a special case, right? I don't want it to just automatically return it because there's a special case. Does anybody want to tell me what the special case is?
You can't divide by 0.
Yeah. What do you get when you divide by 0?
Infinity.
Infinity.
Yeah, and JavaScript will literally tell you infinity. It's not undefined, it's infinity. So we can test this out by console logging this function with its return value. And we'll try 6 and 3, and then we'll try 4 and 0. And what do we expect to get? 6 divided by 3, if we try to use this function, will give us
2.
right? And if I try to divide 4 by 0, I will get
Infinity and beyond.
Beyond and beyond.
infinity and beyond. Yeah. Okay. So let's do this in the thing because this is kind of fun. All right. Yeah, here we go. So I think I got my stuff out of order again. That's okay. Yeah. So let's run this one. Oh, I still have my give me a name. Hold on. Let's console log that out. I'm sorry, comment that out, and then come back to divide nums. Here we go. All right. Okay, yeah. So the first one gave us 2 and the second one gave us 3. So what would happen if I just took this out and I was like, I'm not going to handle that. I'm not going to have an early return. I'm just going to let it return this, right? That's where you get infinity. And infinity is not particularly helpful. I decided to have a little more fun with it than that. So this is kind of a silly case, but you can see that anytime you have any sort of situation where you can think of a special case where you don't actually want your function to follow through the way that it normally would, you can return early by looking for that case and then doing an early return. And then your program will actually stop right here and it won't continue beyond that, because once it hits a return, it returns and boom, it stops. And then it exits and then you're down here. Make sense?
Yes.
Okay. All right. So creating functions. Here's where we talk about like how to use these values. And yeah, so one concept here is, should you return, do you always have to return a value? Are there cases where you don't return values? You've already seen actually lots of examples of where you don't have to return a value. So you don't always have to. And in that case, the return keyword is optional. Can you still put it in there without putting anything after it? Sure. You can just put return, but you don't have to if you don't need to return a value. So common scenarios, changing the value of an external variable like the contents of an array, or toggling a Boolean. And that's the example we're going to look at here in just a second. Logging a message to the console. You've seen that one already where we had our little greet user and we, had a little message. And then triggering another function conditionally, like this is used a lot actually in stuff that we haven't gotten to yet, but like we're going to get to things like event handling in a browser when you're working with a web page. And sometimes you want to like trigger something and then you say, okay, if this is happening, then call this function. But if this is happening, call this function. So sometimes you just need your function to do something for you. You don't actually need a value back. So in this case, we've got this example. Let all prep work equal empty array. I figured this is a pretty, salient example. And then we have this Boolean, let started prep work equal false. So you haven't started your prep work yet. We have a function, submit prep work, and it takes a parameter work so that you can submit something specific. And then if you've submitted, it pushes that to that array, all prep work. And then it also turns started prep work to true, right? So we have a series of commands now after this. We call the function, submit prep work, and we pass in reading. And so once I do that, when I console log started prep work, what do I expect to see?
True.
Yeah, sorry, I was clicking on the wrong thing. And yes, it's true. Because we ran the function, and even though the function didn't return a value, it took care of it for us and it changed the value of something that already existed. And so then we call it again and we say, I want to submit, and I want to submit exercises now. So then we say, okay, I want to go check on the contents of this array. So you console log the array, and what do you expect to see?
But reading and exercises?
Yeah, they should both be in there now because your submit prep work function was silently just stashing those in there every time you run it, right? First we ran it and added reading, then we ran it and added exercises, then we went and we checked on it and said, hey, what's in there? And we could see that it had reading and exercises in it. So no return value needed for this kind of a function. It just was taking care of tasks for us. That's also, it's pretty common. Okay, so using functions, terminology that's important to understand the distinction here is parameters versus arguments. And you've heard me use this a lot already. I say, you call a function. That's a very common way to talk about it. You also might hear people talk about invoking functions. It means the same thing. Once it's been defined, you call it. And for each parameter, you want to pass in an argument, which is the actual data the function needs, and you have to do it in the same order. So in this example, I've got this function format date. I'm giving it a weekday, month, day, and years, and those are all strings. And my parameters are weekday, DD, and YYYY, format, right? And then I'm returning this formatted string where it gives, the day, comma, and then it has the date formatted by month, day, and year with slashes. So it's just a nice way to say, I want a pretty way to display this on my web page. So I'm going to format this information together. So we create this variable, let formatted date, and then we call the function. And we pass in all these arguments. And these are the specific pieces of data that correspond to each of these parameters. So Friday is the weekday, 10 is the month, 7 is the day, 2022 is the year. And then we've got it all stored in this variable formatted date, and we console log it to get the value and printed out for us. So what do we expect to see?
Friday 10/07/2022.
Exactly. And if I had done those in the wrong order and I'd done day first and then month, then it would say 07/10, right? Because it's important. It actually matters what order they're in. Ben, you have a question real quick?
Yeah, given that dating is done differently in the rest of the world versus the US, is there an importance as to which way we should actually be putting dating in our code?
That is a whole nother question. Okay, it is an excellent question. That's a real world application right there. There are actually ways to handle that with internationalization. There's actually libraries out there that will use time zones or other information to do that for you. And it's actually pretty fascinating once you have it all set up. But for your purposes, you cater to your audience, right? So the last company I worked for was strictly working with American people with Social Security numbers and American credit histories. And so we really mostly just focused on doing things in the American way, but we had a lot of employees who are from around the world, and it took them a while to figure this out. I can't just do this the European way because that doesn't make sense to Americans. And of course, it's important to think about that vice versa. If your audience was a worldwide audience, really good question. So yeah, you absolutely want to cater to your audience. Yeah, there's a lot of libraries out there that can help with it though. Okay. So here's where the rubber really meets the road for you guys. How the heck do you use functions? Great. So you've got functions, they do things, they might return values. If they do return values, how do you use them? What do you do with them? So let's talk about that. You absolutely need to do something with it. And some of the, wow, okay, that escalated quickly. Oh, I guess that one didn't have the transitions on it. Yeah, sorry about that. So you can store output in a variable. You can log output directly to a console, or you can use the output of the function by calling the function directly in another expression or in a template literal or something like that. So here's some examples. We've got this function, add 3 nums. you know, 1, 2, and 3. And it's just as simple as adding them up and then producing, you know, it returns that sum, right? So the first example is you can store it in a variable to use later. So you establish a variable, let sum of 3, and you just make it equal to, and this is where you call the function, because the function is going to return something, and that's the value that gets stored in sum of 3. So if I use this and, you know, say add 3 nums, 2, 6, and 1, and then I console log this expression, you know, sum of 3 is, I would expect that my variable now holds the sum of those 3 numbers because I assigned the output of the function to the variable. And we'll look at this in the code in a second. And the second way is to just, you know, print it to the console to see output. This is a very common way to just kind of test that your function's working the way that you expect it to. You just call the function, pass in your information that you want to test it with, and just console log it so you can see the result. That's very much more of a behind the scenes thing than it is like what you would do permanently in your code, but it's very useful. And then of course, calling it directly wherever you need that value to be. So I can just put it right there directly in this long statement, you know, the sum of 8, 27, and 5 is, and then I, you know, have some string interpolation in my template literal. And I just call the function right there, add 3 nums, 8, 27, 5. And I expect that that value will now be part of that sentence because that's what that function returns. This requires you to know what the function does. You have to know what to expect from it, and then you can make good use of it. So let's look at it in the code. Yeah, here we go. I'm gonna comment that out so we can focus on this one. So let's look at these here. We've got the function add 3 nums. It returns the sum. And the first one is where we created a variable and then used the variable. And then the second one is where we're just straight logging it. And then the third one is where we're putting it as part of a full expression in a template literal. So I'll run this and we get sum of 3 is 9, 57. And the sum of 8, 27, and 5 is 40. Does anybody have questions about this? This is important. Yeah. So you guys just want to make sure that you think about, you know, what is your function returning information or not? And if it is, what are you doing with it? Okay. Moving along. All right. Let's talk about parameters with default values. You want sometimes for your functions to be flexible. And it is possible to design a function to take optional parameters. But in order for this to work, you have to assign a default value to that parameter. And you do it when you're defining the function, when you're setting the thing up in the first place. So it looks like this. Let's, you know, we create a function called getFormalName. We pass in first name, last name, and title. But we want title to be optional so that we don't always have to pass something in because maybe some people, we don't have that information for them. So we set it equal to an empty string so that it's, you know, we can not use it if we don't want to. And then we handle it, right? So we start with a string that's going to represent their full name. That's an empty string. And we're going to build this string, but it depends, you know, depending on which information is given to us, we might build it a little differently. So we're only going to use the title and add it to that full string if it exists. So we check and say, is title, you know, an empty string still or not? If it's not, if the function has been used so that something, you know, like, that has substance has been passed in, and there really is a title, then we're going to take that full name variable we created and we're going to tack on title with a space after it. Then we can go ahead and we can add the first name and the last name and return the full name. But if the title is left off, if we only have a first name and last name, that conditional, that loop, you know, the condition there, the expression is going to evaluate to false. It's just going to skip this, right? And so it's going to go straight to just making the full name, the first name and the last name. And then that's what gets returned. So we can see this in practice. Get formal name. Here we go. Hold on. Okay. Yeah, here we go. Okay. Oh, I have a little variation in code here. I'll talk about that in just a second, but let's get this on console uncommented and we'll run it. Okay. So in the first one, I passed in Sarah Jane is the first name, Smith is the last name, and I gave it a title. I used that third optional parameter and it took it and said, okay, there was a title. And so I'm going to add that on, and then I'm going to add on the first name and the last name. And the result we get over here in the console is Miss Sarah Jane Smith. Meanwhile, I've also calling the function, but I don't have, a title. I only have first name and last name. So that's all I'm doing. And because this has a default value up here, I can get away with that. It'll skip this and it'll just return the first name and the last name. There are a lot of different ways to do this code. Let's talk first about what's going on here. You might remember from class 2 that if you convert a string to a Boolean, if it has substance to it, it's true. And if it's an empty string, it's false. So it's very common actually out there in the wild to just do this, to just say if title. Because even though title isn't a Boolean, JavaScript can evaluate it for true or false. And if it recognizes that it's an empty string, this will evaluate to false, and then it'll skip this. So all you have to do is say, if they passed in a title that's actually a title, then, we'll add it. But if this, because an empty string is falsy, if this is false, it skips it. That makes sense? So that's a little shorthand for you. There's things you can do like that. That will, and you might see it out there. And so if you're confused because you're out there looking at somebody's code on Stack Overflow or something, and they pass in something like that as a condition that's not a Boolean, and you're going, how can you do that? This is why, because JavaScript will try to evaluate it as a Boolean, and it can be useful for things like this. Okay, that's the first thing I was going to say. The second thing I was going to say, because I think we have time for this, is we could solve this differently, actually. So let's talk about a different way that we could approach this altogether. This is one of the ways that I want to just convey to you how differently different people think. And so one of you could come up with a completely different solution than the other one, and that's totally okay. What if, instead of trying to do this by building a string, we actually just took advantage of string and array methods that we knew? We could instead say that we want the full name parts to be an array. And we want that array to start off with the first name and last name, because we always, that should be a variable, sorry. Because we always want those to be included, right? And then if there's a valid title, we could say that we want full name parts. And who can remind me how we add something to the front of an array instead of to the back?
Push.
Unshift.
Unshift.
Unshift, good. Yeah, I know it's not one that you use every day, but this is an example of where it's helpful to use it. We could say unshift and use title so that it actually pops it in there in the front. Oh man, pop was the bad word for me to use right there. Sorry about that. Funny how the brain works. Okay, you can just stick it right in there, unshift it, and it will add it. And so now if we were to just go and console log full name parts, we would have title, first name, last name, right? So knowing that, what we can do then is just take full name parts and we can just join it on a space. And whether or not it added the title to that array, it'll work for us. So let's test it and see what happens. Yep, it works. Did everybody follow that?
Yes.
Yeah. So yeah, I mean, a totally different approach to solving the exact same problem, right? One, we build a string, and the other one, we make use of array methods and then, join it to be a string. So, knock yourself out and be thinking creatively, because there are so many different ways to approach things. Okay, let's go back. I think I have one more topic. Yeah, one more topic, 2 slides. So we're doing okay on time. This is good. Okay, function composition. You generally want to keep functions small and focused. Functions should do one thing most of the time, especially utility or helper functions. Those are kind of interchangeable terms that you'll hear out there. You can have one main function to put it all together and then use lots of other functions to take care of specific small tasks. And then by putting it all together, that's composition. This graphic is from one of my resources in my document, my Google Doc, where I talk about how to build a program that has multiple functions. And this is just the typical kind of structure that you're going to see in most programs. The importance will be at the top. Your variables and data will be after that. Any minor functions you've got will be after that. And if you have a main function to run your program, it's usually last. You know, this part, give or take, but this is pretty typical. And it's just kind of a standard, I guess you could call it. And because of this, functions don't have to be sequential. Up until now, everything that you've been taught about JavaScript is that code executes from top to bottom, right? And so the sequence, like if you have a variable that you need to use somewhere, you need to make sure to declare it above that in the code, or else it won't be able to find it, right? Functions are an exception to this. If you declare them with the function keyword, there are other ways to declare functions that we haven't learned yet. But the functions that you're doing now, where you're declaring with the function keyword, JavaScript actually, when it compiles, you remember how we talked a couple classes ago about how there's the 2 stages, you know, JavaScript first, it compiles the code and then it executes the code. When it's in the compiling stage, it actually goes and finds all the functions and queues them up and says, okay, I know where they all are. I know what they're supposed to do. They're ready to go. And then the code executes from top to bottom. And so it doesn't matter if your functions are actually declared way further down in the code, as long as they're done so with the function keyword. So that's why you can kind of get away with having this kind of a structure, because JavaScript can find the function. It's going to already know about the function by the time it executes the code, because it takes care of that while it's compiling. Okay, so with that in mind, let's talk about an example of composition. You want to be smart about how you compose functions and kind of break out the smaller tasks. And you can call functions from within other functions for different reasons. These are just some of the reasons. Like maybe you just have some values that you want calculated and returned. Maybe you're requesting user input. Maybe you're validating user input. Maybe you're printing something to the console. You know, there's handling error messages. There's like all kinds of applications for this. But the idea is that you don't just try to put it all in one big function, particularly because a lot of small functions, and this is where that word utility comes in, they're just useful to have around. Like maybe you have a small function, this is very common actually, that because you know, you guys have learned about how JavaScript has 2 uppercase and 2 lowercase. Some languages actually have a 2 title case type of function. JavaScript does not. So you have to like manually write a little function, a little utility function to put something in title case where only the first letter of the word is capitalized and the rest are all lowercase. So this comes in handy, and that would be something where it would be really smart to put that in a function and just have that as a little utility function that you can grab from whenever you need it, because you might need it in different places, right? So this is the concept. So let's look at these very, very simple examples. They're so simple that you could argue, why would you even bother to do this in separate functions? But it's to serve a purpose, right? Add nums, num1, num2, return num1 plus num2. Pretty straightforward. All this function does is give you a sum. That's its job. The second one prints an equation. It has a very specific format for saying your equation is, and then it's going to give you the equation. So these are our 2 kind of helper functions for our main function, which is add and print. And that has an N1 and N2, which are numbers. I named them differently just so that it would be clear to you guys kind of this concept of the scope of these variables, these parameters as variables and things. So we can do this in 2 steps if we want. We could do it in 1 step, but let's do it in 2. First, we create a variable that's local to this function. That's just sum. And that's where we call addnums and say, you know, let me pass on these values that were passed into this function and take these values and add them up and give me that value back. And I'm going to store that in sum. And then on the next one, we call our other function and say, here's what I want you to print. Here's the equation. And you build this little string with string interpolation that says, you know, n1 space plus space, n2 space equals space, and then sum. And so it's very, you know, everything is handled in a nice, clean way. And I could go and use these functions. Wow, didn't mean to do that. That's what I get for clicking on things. Sorry, guys. Yeah. There we go. To be careful with my clicking as if I'm waving my hands. Okay. You have, those functions could be used in other functions as well. They're useful, right? And in this case, I want to use them from this one. So if I go and do add and print, and I pass in 3 and 7, what am I going to see?
Your equation is 3 plus 7 equals 10.
Yes. Yeah, so let's do it. Exactly. Okay. Anyone have questions about how this works? Because this is what your studio is about, and I want to make sure you understand. Yeah, Mike?
So I know it's probably a specific case, but like where you had a couple of those and you're talking about how one is just sum, you know, and I know you could make it just be, you know, the product of a multiplication or whatever the case is. If, say, for instance, you wanted to use num1 and num2 also in a, I don't know, a division, it would be okay to do that if you wanted both of those results out of something? Does that make sense? Like if you were running something you needed more than just the sum of, it would do both of them for you without having to put those numbers in twice, right?
Yeah,
if you called it.
If you called it, yeah. So you totally could have another like version of this that was for what was that? Was it multiply?
Say multiplication or whatever.
Yeah. Okay. And so then we change this to just being yeah. And then let's say we have another function here that is multiply and print. If I can spell it right. Okay, product is equal to multiply. Did I change the name? Yes, I did. And then I can print the equation, yeah. And this would be times equals product. Okay, so I think I did that all right. So now let's do the same thing, only with, I got a cat climbing on me. You are so silly. Multiply. Okay, let's run it. Yeah, there we go. So in this one, we made use of add nums and print equation. And in this one, we made use of multiply nums and print equation. And so this little print equation guy was pretty handy dandy because we didn't have to have that code twice. We were able to use it from anywhere. Ooh, and
so it's not crazy to think though that like you'd have multiple functions that you'd want to feed the same numbers into if you were using them for different things.
No, I mean, there's so many possible ways that you could do
right.
it.
Yeah, that's
yeah. So and that's something that could be really fun to play around with. Is to, you know, kind of think through the different ways that you might decide to break things out and what's reusable and what's not, and you know what's most efficient. And you could end up making a lot of different decisions that way. And sometimes it's like, do I do it this way? Do I do it that way? And it kind of doesn't matter. So you just pick one, right? Okay. But yeah, so tonight, I think that's a good lead in for studio because we're about at that time. I'm gonna go back to here. This is exactly what you're going to be doing for studio. You are going to first create a function that reverses characters in a string. And then the second part of the studio will be modifying that reverse character function so that it can also handle numbers with digits. And then you're going to create a main function that's going to reverse an entire array. And that means all of the elements are going to be in the opposite order, which you should know how to do with your array methods. But each of the elements also needs to be reversed. All the characters need to be reversed. So let's look at an example just so you can see. When you come to your instructions here, this is all kind of explained. It's very carefully, step by step, they explain it. Here's what you're going for though. You can test by testing with this input. You can give it an array like this, apple, potato, and capitalized words. And it should come out not only with the elements in reverse order, so that apple is last and capitalized words is first, but all of the characters should be reversed as well. But your main function isn't going to do that part. It's going to rely on the first function you wrote. And you're going to call one function from the other function, just like the example I showed you. And then there's a bunch of really fun bonus missions if you have time that will give you more experience with writing functions and thinking through some of these things. This is going to give you a chance to work with, checking types of things when you do the second part to handle digits. But just start simple. Just start with this basic function for reversing characters. Get that down when it's working properly. Just test it like with a single string at a time, right? Once that's working, then move to the next part, then use these to test it. Make sure it still works for strings, but it also works for numbers. And then move on and do the other part and then make sure it all works together. So they give you these nice, this nice sample data to make sure you can test it at different points. Because what you don't want to do is try to write do all three parts all at once and then test it. Because if you have errors, you won't know where the heck that you made them. You want to do it a little bit at a time. So that's tonight. You'll want to, pair up with each other and work together to come up with creative ways to handle all of that. And what did I just do? Here we go. So yeah, so next class on Monday, of course, when your graded assignment is due, the prep work is chapter 11, more on functions. There is more to learn about functions, more than we can do in one class. So we'll do it on Monday. And then on Thursday, we're going to talk about objects. And this is where working with data starts to get super fun and practical. It's a lot easier for me to come up with really practical examples that are like real world scenarios once we get into objects. So yeah, good stuff coming down the pike, guys. Let's go ahead and break. And it's 6:31. Let's come back here at 8 o'clock. That gives you a full hour and a half to work together in studio. And, if you get completely done with the studio and you get done with the bonus missions and you're dying to work on, the rest of your graded assignment, you can use this time for that. Just don't, show each other your code. But yeah, you can do all of that. We'll come back to you at 8. I will go over the solution. We'll talk through, and I will love to hear, did people have different approaches than I have? That's always interesting because people do things differently. Yeah, so without further ado, you guys head out, take a break, and then enjoy your studio time, and I'll see you at 8 o'clock.